Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to learn about composite functions. I have here on the board two different functions. This one's a quadratic function and this one's a linear function. Remember from function notation that I can have some input, like 2. I can put that into my function so that I have 2 times 2 squared plus 3 equals, well, that's 4 times 2 gives me 8 plus 3 equals 11. So remember that function notation, or you can think of it as, I've got this functioning machine here where when I input 2 into this machine then takes it and squares it and doubles it and then adds 3 and out pops 11. Now I have another function over here, a linear function, and I'm going to take this output from my first function and I'm going to put it into this f of x function. So I'm going to take that 11 and put it in here. If I do that, then f of 11 is equal to, 11 minus 2 is 9. So out would pop out. The output there would be 9. So I sent this input into one machine, got an output, and then out came another, put it into another function, and out came the number 9. Now what I want to do is create one function that does this same thing, that when I put in 2, I'm going to get out this output of 9. It's going to do both of these things for me. And the way we do that is we do something called a composite function. So here I'm going to take and notice what we did. We put it through g and we got out this y value of my g function. And this is what that says too. This g of x is just the output of our y function. And we took our g function and we took that and we put it in to the f function. So this we read as f of g of x. And this is a composite function. I like to, whenever I'm working a composite function, I like to just replace that g of x with the function itself. So in this case, my g of x is equal to 2x squared plus 3. So I'm just going to rewrite this as f of 2x squared plus 3 because g of x is equal to 2x squared plus 3. Now, this is just like my function notation. I'm just going to take this and plug it in or substitute it in everywhere I see an x in my f function. So, into my f function, instead of writing this x, I'm going to write 2x squared plus 3, and then I'm going to subtract 2, so minus 2 from that. I'm going to combine those like terms so that I have 2x squared plus 1. Now, this function, this new function, this f of g of x function, is going to do the work of both of our functions. So, if I take and put 2 in for x, just like I did over here, if I take and put 2 in for x into this new machine or into that new function, I should get out 9. This composite function is going to do the work of both of them. So when I put it in, 2 squared plus 1, 2 squared is 4, 4 times 2 is 8, 8 plus 1 really does 9. So this new function does the work of both of these other functions. This we call a composite function. We've created a new function that does the work of both of those functions. Now, this terminology, f of g of x, notice that I could do it the other way around too. Let's do g of f of x. In other words, this time, I'm going to start with my f of x. I'm going to input into this machine so that when I input in my 2 here, 2 goes in for x, well 2 minus 2 gives me 0. Once I have that output, that f of x value, I'm going to take it and put it in the g. So that's what's happening here. I'm going to put it in the f of x, and then whatever that output is, I'm going to put it into my g. So 0 squared is 0, times 2 is still 0, plus 3 gives me an output of 3. So going in the other direction, notice I got a different output. So these two things are not the same. They're two different machines. So I'm going to find this g of f of x that does the function, does the work of both of those things. And I'm going to start by replacing that f of x with x minus 2. And that just lets me know that I'm now going to put that x minus 2 in. I'm going to substitute it in everywhere I see an x here in my g function. So instead of writing that x, I left off the x. Instead of writing the x, I'm just going to write x minus 2. I'm going to simplify. So 2 times x minus 2 times x minus 2 plus 3. Do some distribution. I'll multiply this 2 times the x minus 2 first, so that I have 2x minus 4 times x minus 2 plus 3. Distribute. So, first times first, 2x squared. 2x times a negative 2 is a negative 4x. Negative 4 times x is a negative 4x. And a negative 4 times a negative 2 is a positive 8. 2x squared minus 8x plus 11. Now this is my g of f of x. I have found the composite function there. I can test to make sure that this function is doing the job of both of them by plugging in 2 into the equation. And if I plug in 2 everywhere I see an x, I should get out a 3 if it's doing the work of both. So let's just test it. 2 squared is 4. 4 times 2 is 8. 8 minus 16 is a negative 8 plus 11 really does give me 3. So here I've created 2 different composite functions. And also notice that, that the f of g of x and g of f of x are not equal to one another. So we've created a new function that, that does the work of both functions in both cases. So there's your introduction to a composite function. We'll do some more examples in the next video. Math Made Simple at Simpson Math. Thanks for watching.